Hey guys, Mr. Wilson here. Today we're going to talk about conditionals and converses. At the end of this video, you should be able to identify a conditional as well as its parts. You should be able to write a converse from a conditional, and you should be able to determine the truth value of a conditional and provide counterexamples when necessary. Okay, last lesson we looked at inductive reasoning, and the next couple of lessons we'll look at deductive reasoning. Okay, remember deductive reasoning. Deductive. Okay. Deductive reasoning is when you start with a general rule and you make a specific conclusion. Okay? So, we'll start with a conditional statement. Now, a conditional statement is one that can be written in an if-then form. So, if this, then that. It has two parts. It has the hypothesis and the conclusion. Okay, the hypothesis is the if part, and the conclusion is the then part. So we'll just make sure that we understand that looking at this example. Identify the hypothesis and conclusion of the conditional statement. If I eat fast food, then I am unhealthy. Okay, so I'm not saying that this is a true or false statement, but the hypothesis says I eat fast food. Then the conclusion, I am unhealthy. Okay, notice that the hypothesis does not include the word if, and the conclusion does not include the word then. Okay, so those are kind of just markers for us. They are not included in our hypothesis and conclusion statements. Okay, conditionals have a truth value. They are either true or false. So truth value just means is it true or is it not? And to show a conditional is false, just like before, you only need to provide one counterexample. Okay, an example that something is opposite of what you just said. Okay, a counterexample is an instance when the hypothesis is true, but the conclusion is false. Okay, in our if I eat fast food, then I am unhealthy example, you might say LeBron James eats McDonald's and he's healthy. That's a counterexample. Okay, or I eat McDonald's, but I run 3 miles a day, so I feel like I'm healthy. Okay, that's a counterexample. Provide a counterexample if possible for the following conditionals. If a figure is a quadrilateral, then it is a square. Okay, counterexample would be a rectangle. Okay, so remember, for a counterexample, you have to provide a specific example that something is not true. You cannot just say, if a figure is a rectangle, it doesn't have to be a square. That is not a counterexample. Okay, a counterexample, you need to provide what it could be. Okay, if a figure is a quadrilateral, then it's a square. Well, a quadrilateral could be a rectangle, and rectangles and squares are different. Squares have all 4 sides the same. Rectangles have 2 sides, or 2 pairs of congruent sides. Alright, provide a counterexample if possible for the following conditional. If absolute value of x is greater than 0, then x is greater than 0. Well, what about negative 1? If x equals negative 1, its absolute value would be 1, greater than 0. But x, negative 1, would still be less than 0, so this would not be true. Okay, so you see that we're taking, when I say that the hypothesis is true, we're saying this first part is true. If this first part is true, but the second part is false. So we're saying it is a quadrilateral, but it could be a rectangle. Absolute value of x is greater than 0, but x, negative 1, is not greater than 0. Alright. Flipping to the back side here. Alright. Now, we are able to write conditional statements given a statement. So we'll jump into that with an example. An acute angle measures less than 90 degrees. We want to make this a conditional statement. And so we can do that. Make sure you remember conditional is the if-then form. So we say, if an angle is acute, okay, that's our hypothesis. An angle is acute, then it measures less than 90 degrees. Okay, so if an angle is acute, then it measures less than 90 degrees. And now we have that statement written as a conditional. Okay, Venn diagrams can also be used to illustrate conditional statements. So we're going to use this Venn diagram just so you guys can see how that happens. And remember, we go from a specific to a general. So we can say, if a conditional we have this Venn diagram, we have Olympians and athletes. And so what I can say from this conditional, or from this Venn diagram is, in order to be an Olympian, you have to be an athlete. So I say, if, I'll just say one, or a person, but I'll say one to write less. If one is an Olympian, comma, then he is an athlete. Okay, universal he here, guys and girls. Okay, so if one is an Olympian, then he is an athlete. From here, to make a rule. Okay. All right. And so since we can write a conditional from a Venn diagram, we can make a Venn diagram from a conditional. So it says if you live in Chicago, then you live in Illinois. So what we have here, I don't really know a whole lot of cities in Chicago or Illinois, but I know that Illinois is the big state. Okay, Chicago is one city. Okay, so we have all the cities, whatever, in here. Say Chicago. This is Chicago. Chicago. Okay. So if you're in Chicago, you live in Illinois. Okay. Can you live in Illinois without living in Chicago? Yes. So Chicago is a smaller part of this. All right. Let's talk about converses. Okay. We talked about conditional statement. The converse of a conditional statement. Flips the hypothesis and the conclusion, or switches. You can say one of those two. Okay, so symbolically, we had P then Q, so we go Q then P. Okay, conclusion then hypothesis. So let's look at how that actually works out in practice. Write the converse of each conditional statement, or each conditional. Determine the truth value of each statement. So our conditional statement, if x equals 9, then x plus 3 equals 12. Its converse says if, now we're switching the hypothesis and the conclusion, if x plus 3 equals 12, then x equals 9. So we're going to look at the truth value of the conditional. Is this conditional statement true? Yeah. If x equals 9, then 9 plus 3 equals 12. Yes. Truth value is true. Okay, and now we can look at the truth value for the converse. If x plus 3 equals 12, then x equals 9. Yep, that's true as well. They are both true. Up so I don't have to move this anymore. Okay. Next, if you travel legally from US to Kenya, then you have a passport. Alright, and now we'll do the opposite way. the converse. If you have a passport, then you travel legally from U.S. to Kenya. Okay, from U.S. to Kenya. If I don't fit this all in here, you know what I'm saying. Okay, truth value of the conditional. If you travel legally from U.S. to Kenya, then you have a passport. That is true. In order to travel legally, you need to have a passport. Converse, if you have a passport, then you travel legally from U.S. to Kenya. Well, I have a passport, but I've never traveled from the U.S. to Kenya. So I know that that is false. Okay, you can have a passport and not travel to Kenya. You could just be traveling to other places. Number 3, if a squared equals 25, then a equals 5. Okay, the converse would be, we'll do it. The converse would be if a equals 5, okay, a equals 5 being our hypothesis, then a squared equals 25. Okay. Truth value of the conditional statement. Now, if you said true, slow down. It's false. Okay, because if a squared equals 25, a could be 5, but a could also equal negative 5. Okay, truth value of the converse is true. Okay, because if a is 5, 5 squared is 25. Okay, so hopefully after this video, you're able to identify the parts of a conditional. You're able to write a conditional statement, and you're also able to identify and write a converse and tell the truth values. All right, see ya.